Very good morning, students. Today we are going to learn new chapter, that is binomial theorem. So let us understand what is binomial first. So binomial is an expression in which there are two terms. For example, x plus y, this is a binomial. 2x plus 7, this is a binomial. So these terms are going to call it as binomial. Why? Because they are consisting of two terms. Now our chapter name is binomial theorem. So in order to understand what is binomial theorem, let us recall some identities. X plus y whole square, which is given as x square plus 2xy plus y square. Next, x plus y whole cube, which can be written as x cube plus 3x square y plus 3xy square plus y cube. Next, x plus y whole square whole to the power of 4 can be written as x plus y whole square, x plus y whole square. So that is x plus y whole square and x plus y whole square can be written as x to the power of 4x cube y plus 6x square y square plus 4xy cube plus y to the power of 4. So this is the expansion form of, if I multiply this expansion into this expansion, I am going to get this expansion. So if you observe all this expansion, it may be anything also. For example, if it is x to the power of 100, so it will take more number of terms for us to get. So that's the reason they have introduced one theorem called it as binomial theorem. Why we are using this concept binomial means here there are only two terms. So in each and every question of this identity, we are having only two terms. So these terms comes under binomial. Now we are going to define what is the binomial theorem. Why we are defining this binomial theorem is we can expand up to some powers, but when it comes to 100 power, then we cannot write all the 100 terms. That's the reason we need a special concept over here. That concept is, we are going to call it as a binomial theorem. So in order to introduce the binomial theorem, we need to keep in our mind three things. The first thing is that the number of terms. So number of terms in expansion. Whatever the number of terms that are there in the expansion, it will be n plus 1. It means that if the power is n, then the number of terms will be plus 1. For example, here the power is 2. So the terms are 1, 2, 3. 2 plus 1, which is 3. Here the power is 3. The terms are 1, 2, 3, 4. Here the power is 4. The terms are 1, 2, 3, 4, 5. So always make sure that number of terms in the expansion will be n plus 1, where n is power or index, whatever we can call. Next, the second point is that sum of the powers of variables is equal to n value. Okay, let us try to understand the sum of the powers of the variables. So for this variable, the power is 2, which is n value. Here the power will be x also power 1, y also power 1, 1 plus 1, which is 2. Here y, it is a normal variable, but the power is 2. So whatever the powers that are there, it will be equal to n value. That's what I have done. If you observe, here it is 4, here also 3 plus 1, 4, 2 plus 2, 4, 1 plus 3, 4, and y to the power of 4. So these are the 2 points which we need to remember while doing the expansion of this. Next point is that power of variable x. Power of variable x decreases, this is the decreases symbol, and y increases. So if you observe here, x power is here 2, here 1, and here no power. It means that x to the power of 0. So x power is keeping on decreasing in the expansion, and y power is keeping on increasing in the expansion. So these are the 3 points which are going to include in our binomial expansion. So let us see if there are n terms, so if there are 2 terms, 3 terms, if it is power 4, we are doing, but if the power is n, so how to get this binomial theorem expansion, let us see. So we have already seen that combinations. So binomial theorem, if the number of terms are n, if the number of terms are 2 and power is n, then x plus y whole to the power of n is given as nc0 x to the power of n plus nc1 x to the power of n minus 1 y to the power of 1 plus nc2 x to the power of n minus 2 y to the power of 2 plus nc3 x to the power of n minus 3 y to the power of 3 plus and so on, plus ncr x to the power of n minus r y to the power of r plus and so on, ncn y to the power of n. So this is the formula for using this binomial theorem for any power. For if the power is 10, for the power is 100, we can do for all the things. So here, this we can get the coefficients of this binomial theorem by using the Pascal's triangle as well. So let us talk about the Pascal's triangle. Pascal is one mathematician who has introduced this, how to get this coefficients of this binomial theorem. So first is 1, next 1 as such we are going to write next 1, 2, 1. Next 1, here 1, 1 plus 2, 3, 2 plus 1, 3. We can write like this. Okay, next 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Here 1. Next expansion we can write 5, 10, 10, 5 and 1. So this is expansion for 1C0. This is 2C0. This is 3C0. This is 4C0. 5C0. So this is 1C0, 1C1, 2C0, 2C1, 2C2, 3C0, 3C1, 3C2, 3C3, 4C0, 4C1, 4C2, 4C3, 4C4. So like that. This is the starting series. So if you remember this Pascal's triangle coefficients, it will be very easy for us to do the calculations. Okay, here minus 4C1 plus 4C1, it gets cancelled. Next minus 4C3 plus 4C3 gets cancelled. Okay, 4C0, 4C0, it is double. So I can take 2 times, that is 4C0 2x square whole to the power of 4 plus 4C2 2x square whole to the square into third root of 1 minus x square whole square plus 4C4 3 into 1 minus x square whole to the power of 4. So we know the values of 4, 1, 4, 6, 4, 1. So this is 4C0, this is 4C4. So we want 4C0 value, that is 1. So 2 into 1 into 2 is square. So 1 into 2x square whole to the power of 4 plus 4c2, 4c1, 4c2, that is 6. So 6 into 4x to the power of 4, 3 square into 1 minus x square, plus 4c4, which is 1, 3 to the power of 4 is 81 into 1 minus x square whole square. So if you further simplify, you are going to get an answer. So among these two, we have to see that which one is larger. So let us start by using the binomial theorem solution. So first let us take 1.01, totally 6 zeros. So this can be written as 1 plus 0.01 whole to the power of 10 crores. Sorry, it is 10 lakh. Okay. Let us expand. This is a plus b whole to the power of n, which is C0, 1 plus C1, 1 to the power of 1 lakh, 10 lakhs, 1 to the power of 0.01 plus 62, so 1 to the power of minus 2, 0.01 whole to the power of 2, plus so on some positive terms we can consider. There are a lot of terms. So anything to the NC0 value will be 1. So the 1 to the power of something will be 1. So this total value is 1. So this is 10 lakh. C1 will be 10 lakh only. Okay, here into 0.01. So this can be written as 1 by 10 lakh divided by 100. 2 zeros, 2 zeros get cancelled. 10. So 10,000 plus 1, that is 10,001 plus some positive terms. So there are again more terms, but we are not taking all into consideration. Plus some positive terms. All are positive only. Okay. If you compare this and this, 10,000 plus 1 here, 10,000 only. So we can say that therefore 1.01 whole to the power of 10 lakh is greater than 10,000. Let us start doing this coefficient solution by using the binomial theorem. So given x square minus 1 by x cube whole to the power of 6. So this can be written as 6c0 x square whole to the power of 6. Alternative symbols, why? Because minus. So 6c1 x square whole to the power of 5 into 1 by x cube plus 6c2 x square whole to the power of 4 1 by x cube whole square plus 6c3 x square whole cube 1 by x cube whole cube plus minus plus minus plus. So 6c4 x square whole square 1 by x cube whole to the power of 4 minus 6c5 x square into 1 by x cube whole to the power of 5 minus plus 66 1 by x cube whole to the power of 6. So if I simplify this, 6 is 0, it will be 1. So that is x to the power of 12 minus. So let me write by using a Pascal's triangle. That is 1, 5, 10, 10, 5, 1. This is for 5C0. Next, if we talk about 6C0, that is 1, 6, 15, 20, 15, 6, 1. 3, 4, 5, 6, 7. So 7 terms. So 6C0 value is 1. Next 6C1 value is 6. So that is 6 x to the power of 12 minus, x to the power of 10 by x cube plus 62, that is 15. So 15 x to the power of 8 by x to the power of 6 minus 63, 20 x to the power of 6 by x to the power of 9 plus 64, 15 x to the power of 4 by x to the power of 12 minus 65, 6 x square by x to the power of 15 plus 66, 1, that is 1 by x to the power of 18, 6 3 by 18. So next step, it will be x to the power of 12 minus 6 into x to the power of 7 plus 15 into x square minus 20 into 1 by x cube plus 15 into 1 by x to the power of 8 minus 6 into 1 by x to the power of 12 plus 1 by x to the power of 18. So our question is, what is the coefficient of x to the power of 6 and x square? X to the power of 6 coefficient we need to find out, and x square coefficient we need to find out. So here both the terms are in the same way. So here he is asking the coefficient of x power 6. So coefficient of x power 6 is 0. Why? Because there is no coefficient of x power 6 here. Next, coefficient of x square. So coefficient of x square is 15, since it is 15 here. So this can be done by using the general term formula also. So first let us see what is that general term. If the given binomial expansion is a plus b whole to the power of n, that is nc0 a power n plus nc1 a to the power of n minus 1 b plus and so on, plus ncr a to the power of n minus r b to the power of r plus and so on, plus ncn b to the power of n. Here general term is denoted by t of r plus 1. That is given by t r plus 1 is ncr a to the power of n minus r b to the power of r. So this is the general term of the given binomial expansion. So for any coefficient, if he is asking, we can use the general term formula and we can find out. Now since the given question is x square minus 1 by x cube whole to the power of 6, n value is very clear that it is 6, we don't know the r value. So let me substitute in this, it will be 6cr, a value is x square whole to the power of 6 minus r, b value is minus 1 by x cube whole to the power of r. So that is 6cr x to the power of 12 minus 2r, so minus 1 to the power of r into 1 by x power 3r. So this can be written as 6cr x to the power of 12 minus 5r into minus 1 whole to the power of r. So this is t of r plus 1 Now we can find the coefficient of x power 6. So we are going to equate the powers of x. Equate powers of x. So that is 12 minus 5r is equals to 6. So minus 5r is equals to minus 6, r is equals to 6 by 5. Since we are getting r value as a fraction, so we don't have any kind of fractional values. Therefore, coefficient of x to the power of 6 is 0. Similarly, in order to get the coefficient of x square, equate the powers of x. Equate the powers of x, that is 12 minus 5r is equals to 2. So 10 is equals to 5r, r is equals to 2. So we need to substitute r value as 2. So that is 6c2 x to the power of 12 minus 5 into 2 minus 1 whole square. So 6c2 value is 15 x to the power of 2 into 1, that is 15x square. Therefore, coefficient of x square is equals to 15.